Welcome to this .NET MAUI Cartesian Charts tutorial. In this video, I will show you how to visualize missing and abnormal website traffic data using an AI service in the Syncfusion .NET MAUI Cartesian Chart. First, I open an existing MAUI application. I've already configured the .NET MAUI Cartesian Charts control and specified a line series to visualize e-commerce website traffic data. To learn how to add the .NET MAUI Cartesian Charts control to your MAUI application, watch the video linked in the YouTube card above or the description below. Now, I'll run the application. You can see the line series displayed with empty data points. Now, I will show you how to visualize missing and abnormal website traffic data in a .NET MAUI Cartesian Chart using an AI service. I will begin by integrating the AI service into the application. So, I open the NuGet Package Manager and switch to the Browse tab. I search for the Azure AI OpenAI NuGet package, select it, and then install it in my project. In this example, I will be using Azure OpenAI. However, you can choose any check completion service. If you decide to use Azure OpenAI, make sure that you have access and have configured deployment through the Azure portal. To securely authenticate the Azure services without storing API keys, I install the Azure Identity NuGet package. Additionally, I install the Microsoft Extensions AI OpenAI package, which allows for seamless AI integration into applications. Once these packages are installed, I create a class called Azure OpenAI Service to handle interactions with Azure OpenAI. I begin by declaring three constants: endpoint, to specify the Azure endpoint URL for API calls, deployment name, which is the name of the AI model, and key, the API key for authentication. These values are essential for connecting to Azure OpenAI. I also add two internal properties: client, which represents the AI model interface, and chat history, which stores the conversation history. To ensure that the application can communicate with Azure OpenAI services and handle AI requests, I create a method named getAzureOpenAI and call it in the constructor. Within the try block, I create an instance of Azure OpenAI client using the provided Azure endpoint and API key. Then, I store the created OpenAI client instance in the client property. To process and clean e-commerce website traffic data, I create a getCleanedData method. In this method, I define a collection to store the cleaned data. I construct a prompt that instructs OpenAI to clean the data, remove outliers, and fill in missing values. Within the try block, I check if the client exists and store the prompt in chat history. Next, I call the completeAsync method to send the chat history to Azure OpenAI. Then, I extract the AI-generated response and pass this response to the cleanedData method to convert the AI output into structured data. Now, I move to the cleanedData method. In this method, I check whether the response is empty. If it is, I return an empty collection. Otherwise, I split the response with line breaks to process each record separately. In the for-each loop, I iterate through each line and skip any empty lines. Then, I split each line into date time and the number of visitors, and store them in a collection. I return to the getCleanedData method. Within the catch block, if an error occurs, I call the getDummyData method, which contains predefined data. Finally, if any failure occurs, I return the empty collection. Next, I move to the ViewModel class. I create a property, cleanedData, to hold the AI process traffic data and initialize it in the constructor. I create another property of type Boolean to control the loading indicator in the UI. In the constructor, I set the isBusy property to false, as no processing is needed initially. After that, I create the method loadCleanedDataAsync to clean the raw data by sending it to Azure OpenAI and updating the cleanedData collection. Within this method, I create an instance of Azure OpenAI Service, which handles AI requests. I call the getCleanedData method, which sends raw data to Azure OpenAI and receives a cleaned version of the data. Finally, I set the isBusy property to false to notify the UI that data processing is complete. In the main page, I create an onParentSet method, which is called when this page is added to a parent. Within this method, first I call the base class method to ensure the default behavior is maintained. I set the isBusy property to true, which triggers a UI loading indicator. I introduce a delay for 2 seconds before calling the loadCleaned data async method. Next, I move to the main page XAML and create a line series to display the clean data. To indicate progress during data processing, I use the Syncfusion .NET MAUI Busy indicator control. The indicator's visibility and animation are controlled by binding the isBusy property to the isVisible and isRunning properties, ensuring that it is displayed and animated only as needed. For a better visual experience, I configure the animation style to show 2 circles rotating in opposite directions. Once the application is loaded, you will see the indicator loads and displays the cleaned data. Let me wrap up this video. You have learned how to visualize missing and abnormal website traffic data using an AI service in the Syncfusion .NET MAUI Cartesian Chart. If you want to see this example's working code, download it from the GitHub link in the description below. I have also included a link where you can check if you qualify for our community license, which gives you a free license key for our entire .NET MAUI controls. If you found this video helpful, click the like button and subscribe to our channel to watch more videos like this. Thanks for watching.